You are welcome to Science Tutorials with Eternity the Schoolboy. Today we are going to take a look at chemistry. The question before us is, what is a buffer solution? Answer. A buffer solution is a solution that resists a change in pH whenever a small amounts of a strong acid or a strong base are added to the solution. A buffer solution can also be referred to as or called pH buffer or hydrogen ion buffer. Actually, a buffer solution is an aqueous solution which consists of a mixture of a weak acid and a salt of its conjugate base. A buffer solution can also be a mixture of a weak base and a salt of its conjugate acid. Now, the key point there now is conjugate acid as well as conjugate base. What is a conjugate acid? A conjugate acid is a species that is formed when a proton is added to a base. By proton, we mean hydrogen ion. While a conjugate base is formed when a proton is removed from an acid. So basically, a conjugate acid is formed from a weak base, while a conjugate base is formed from a weaker acid, just by transfer of a movement of proton or hydrogen ion. Now, let's take a look at this. I want to use this table to explain what I mean. This table, it doesn't necessarily contain only weak acid. Yes, there are strong acid there, but I just want to explain what basically a conjugate acid is. From a conjugate base, an acid, a conjugate acid, and a base. Previously, I defined a conjugate base must not necessarily come from a weak. No, it can be a strong acid, but the most important thing is this: it came from an acid. But when you talk of buffer, the acid from which the conjugate base came from must be a weak acid for it to be a buffer. The same thing, a conjugate acid must not necessarily come from a weak base, but for it to be a buffer, the conjugate acid must come from a weak base when a strong acid is added. When a strong base is added. Now, let's continue. Now, look at this table. This is hydrofluoric acid, HF. It's an acid and it's strong. But look at its conjugate base. If this HF loses this proton, it will form fluoride ion. So fluoride ion is a conjugate base of hydrofluoric acid. The same thing, bromide ion is a conjugate base of hydrobromic acid when it loses this hydrogen, which is hydrogen ion. The same thing now, triazonitrate 5 ion is a conjugate base of triazonitrate 5 acid. The same thing, hydrogen tetraoxo sulfate 6 ion is a conjugate base of tetraoxo sulfate 6 acid. Now look at this weak acid. This ethanoate ion is a conjugate base of this weak acid, which is ethanoic acid. Now let's go to conjugate acid and their bases. Hydrozonium ion. Remember, the conjugate acid is formed by adding hydrogen or hydrogen ion to what? Conjugate base. When this water now react with a strong what? Acid, what will happen? There will be a transfer. Hydrogen will be transferred to this water. And when this is done, it will form what? A conjugate acid. So hydrosodium ion is a conjugate acid of what? Water. The same thing now, ammonia, when react with a strong what? Acid, to form what? This ammonium ion. So ammonium ion is a conjugate acid of ammonia. Now, at this juncture, I want to explain something else. This now will lead us to what we call conjugate acid base pair. Conjugate acid base pair. Actually, buffer solution has a lot to do with. It's all about conjugate acid base pair. Don't worry, let's continue. Now, types of buffer solution. There are two types of buffer solution. We have acidic buffer solution and basic buffer solution. I've mentioned it here, but let me just explain it better here. Acidic buffer solution. What do you understand by acidic buffer solution? An acidic buffer solution is a solution that contains is a buffer solution that contains a weak acid and a salt of its conjugate what? Base. You can simply put, it contains a weak acid and its salt. The salt it forms with a strong base. Now, this acidic buffer solution is used to maintain acidic pH. An example of acidic buffer solution is the buffer solution that contains ethanoic acid or acetic acid and the sodium ethanoate or sodium acetate. While ethanoic acid is the what? The weak acid. Now, sodium ethanoate is the salt of the conjugate acid, conjugate base of ethanoic acid. Remember that the conjugate base of ethanoic acid is this ethanoate ion. When this ethanoate ion react with what? Hydrogen, sodium hydroxide, it will form sodium ethanoate. So that's why I said the salt of its own salt with a strong base, or a salt of its conjugate what? Base. So ethanoic acid is the weak acid. Sodium ethanoate is the salt of the conjugate base of ethanoic acid. So this is an acidic buffer. The second one is the basic buffer solution. Basic buffer solution is formed between, or it contains a weak base and the conjugate and salt of its conjugate acid. A weak base and the salt of its conjugate acid. An example, or simply put, you can simply say that basic buffer solution contains a weak base and its salt, that is the salt it formed with a strong acid. Look at it here. The weak base here now is ammonium hydroxide. The weak base now here is ammonium hydroxide. This ammonium hydroxide, ammonium chloride is salt of conjugate acid of ammonium hydroxide. So this mixture will form a what? Basic buffer solution, and is used to maintain an alkaline pH. Now, how does a buffer solution actually resist changes in pH? Now, before we can explain this, I want to go back to a definition we gave before on buffer solution to redefine it. Redefining a buffer solution, having in mind the concept of conjugate acid-base pair. conjugate acid-base pair. I can define a buffer solution as a mixture of conjugate acid-base pair that can resist changes in pH when small volume of acid or strong acid or bases are added. That is the definition of this with respect to conjugate acid-base pair concept. Now, what is this acid-base pair? We have been showing it here as conjugate acid-base pair. Look at it now. A pair of this acid and its conjugate base, and a pair of this base and its conjugate acid is what conjugate acid-base pair is all about. Now, we did that in our back of our mind. Let us now go into talk about how buffer solution resists changes in pH. Now, let me start from neutral solution. Neutral solutions like water and neutral solutions like sodium chloride solution, they have neutral pH. If you add strong acid, let me use water, in water, the pH of water naturally will do what? Decrease from neutral to less than 7. Why? Because the water is not buffered. Now, if you add a strong base, the pH will do what? Increase above 7. Still, because the water is not buffered. There's nothing in the water that will maintain the pH at that neutral level. But if it is buffered, if it contain any of this solution mixed of any of these conjugate acid-base pairs, see what will happen. If you add strong acid, remember strong acid, when ionizes, contains hydrogen ion. Now, what will happen is this. The basic components or the conjugate base, for example, now if you are using an acidic buffer, the conjugate base of the acidic buffer will do what? Will attack the hydrogen ion from the strong acid you added. And when this happens, it will neutralize the acid, thereby maintaining the what? The pH at that specific level it was. Now, if you now go and add, let's assume what you now added is strong base. Of course, base produce hydroxide ion. Now, the weak acid components will go and react with the hydroxide ion and neutralize the base, thereby resisting increase in what? pH. Of course, when you added acid, the effect is to resist decrease in pH. Now, when you add base, it will resist increase in pH. This is how it works. Now, let's bring it down to simple equation. Let's assume that the acid component is HA. Remember, the basic component, or simply put, the conjugate base for a weak acid, for an acidic buffer solution is this. This is the conjugate base. So a buffer solution will not contain this is the acid, this is the weak acid, this is the weak acid, and this is the what? Conjugate what? This is the what? Conjugate what? Base. This forms a buffer solution. Now, if you now add a strong base, of course, base will always have OH. This weak acid component will go and react with the OH from the base and neutralize it, form water and the conjugate what? And the conjugate base. Now, it will not resist increase in pH. The pH will not increase. Now, let's assume that what you added is a strong acid. Hydrogen ion comes from strong acid, from acid. Now, this component, this conjugate base component, will attack the hydrogen ion from the strong acid and neutralize it to form this. And when this happens, the pH will not be allowed to go down. It will maintain it at that particular level. So this is basically how buffer solution resists changes in the pH. Now, yes, we have basic acidic buffer solution and basic buffer solution. But the one that is commonly used is acidic buffer solution, which contains weak acids and their conjugate bases. Now, this equation I wrote here now, if I continue breaking it down, it will lead to what is called a buffer equation, which is also called Heisenberg equation. I will go into this, wait for pharmaceutical calculation on buffer solution, or some questions that will arise in calculation involving buffer solution. I will now introduce this equation and use it to do calculation. Stay tuned on our YouTube channel for more details for further lectures on this equation. I wouldn't want to go into it because we are just trying to define or explain what buffer solution means. Now let's continue. How do we now prepare a buffer solution? The simplest method, there are different methods, but the simplest method of preparing a buffer solution is just by mixing a weak acid. That is, if you want to prepare an acidic buffer solution, mixing a weak acid with the salt of their conjugate bases. Once you get a weak acid and mix it with the salt of their conjugate base, of its conjugate base, mix them together, you have formed a buffer, an acidic buffer. Example, ethanoic acid and sodium ethanoate will form an acidic buffer. If you want to form a basic buffer, you get a weak base and mix it with its conjugate acid. By that means you have formed a basic buffer solution. Example, sodium hydroxide and ammonium chloride mixed together will form what? Did I say sodium? I say ammonium hydroxide, not sodium hydroxide. Ammonium hydroxide and the ammonium, not ammonium hydroxide and the ammonium chloride will form a basic buffer solution. This is the simplest method of buffer solution preparation. Let's continue. Now I want to go a bit to talk about examples of buffer solution and use of buffer solution in the biological system, and also examples of buffer solution used in pharmaceutical formulation, and the actual use of buffer solution in some uses of buffer solution in pharmaceutical formulation. We will round up there. Now let's talk about in biological system. There are three important buffer solution in biological system. I won't go deep. Number one is what? We call it carbonic acid and bicarbonate buffer solution. Carbonic acid and bicarbonate buffer solution contains trioxocarbonate 4 acid and its conjugate base, which is bicarbonate ion. This helps to maintain, of course, using the normal method through which buffer solution resists change in pH. They tend to maintain the pH, the homeostasis, the pH homeostasis of the blood, maintain the pH of the blood. Now we have another one that also play some role, but not that much in the blood. We call it phosphate buffer system. It contains phosphoric acid and dihydrogen phosphate ion. phosphoric acid and dihydrogen phosphate ion. This combination form a buffer solution we call what? Phosphate buffer system. We also have protein buffer system. Let's not go deep. Now let's continue. We also now, in pharmaceutical preparations, there are about I want to talk about 3 important uses of buffer system in pharmaceutical preparation. Number 1, there are some formulations that are directly administered into the body fluids, and these body fluids, one thing about this body fluid is that the body fluid is highly pH, anyway, some that are highly pH sensitive. So those formulations are buffered so as to maintain the pH of the body fluid. Example of such formulation is, you find it in injections and some ophthalmic formulation. Ophthalmic eye preparation, drugs, medicines used in the eyes. They need to be buffered so as to maintain the pH of the body fluid where they are administered. Now, there are also some formulation that are stable at a specific pH. Once there's a shift in the pH, their stability will be questioned. In fact, they may become unstable, they may decompose, degrade. So the pH needs to be maintained. So in such situation, there's need for it to be buffered. Now, also there are some pharmaceutical tests and pharmaceutical assays that requires to be carried out at a specific pH, mainly for analytical purposes. In such situation, you will need to do whatever you are going to do there, there's need for it to be buffer, so to maintain this pH. Now, some examples of buffer solutions used in pharmaceutical preparations, formulations. Some examples of them are, we've mentioned one before, acetic acid and sodium acetate, that is ethanoic acid and sodium ethanoate, that is ethanoic acid and what? Sodium ethanoate. And that one is what? Boric acid and sodium borate. Mixture of boric acid and sodium borate. Mixture of boric acid and sodium borate. And that one is disodium phosphate and sodium acid phosphate. These are few examples of buffer solutions used in pharmaceutical preparations. You can research more on that. I just started to, because of for those that may be interested in pharmacy or those that are already in pharmacy school, I just decided to mention biological and pharmaceutical so that we appreciate it more. All right, we'll stop here for today. Please, if you have any question, please chat me up on WhatsApp. My WhatsApp number is on this screen. Chat me up so that we can attend to your question. Now, you can also subscribe to our YouTube channel. We have our Academy YouTube channel, Purify Academy. You call it Suzem Academy. You can subscribe to it and click on the notification button or bell so that you'll be notified whenever we post new videos. Our academy, as I said before, our academic YouTube channel is Suzem Academy. You can also do the same for our general, company YouTube channel, Suzem Limited. You can also do the same to my personal YouTube channel. The name is Pharmeternity, the Schoolboy. My name is Pharmeternity, the Schoolboy. Thank you very much for your attention. See you next time. And God bless you as you subscribe. Bye-bye.